organisasi dengan jabatan kerja yang baru, dengan struktur yang baru, nah efektivitas organisasi, sehingga baru sempat pada hari ini di jam yang sama sedang melaksanakan pelantikan untuk jabatan fungsional tersebut. Jadi seluruh Indonesia saat ini Kementerian PUPR sedang melaksanakan pelatihan. Oleh sebab itu, maka izinkan saya sampaikan permohonan maaf kami selaku perwakilan dari Balai Penerapan Teknologi Konstruksi Kementerian PUPR tidak bisa membuka secara resmi, secara langsung dari Bapak. Oke. Yang pertama, saya sampaikan terima kasih juga kepada PT Piranti Sarana Technologi ya, karena sudah mau bekerja sama dengan Balai Penerapan Teknologi Konstruksi untuk bisa menyelenggarakan kegiatan ini. Mudah-mudahan dalam beberapa rangkaian kegiatan kali ini, yang saya lihat di sini ada 5 kegiatan ya, yang sudah kita mulai dari hari Senin kemarin dan akan terus berlanjut sampai dengan hari Jumat, dengan beberapa topik yang sangat menarik menurut kami dan kekinian. Mudah-mudahan apa yang bisa capai pada kegiatan kali ini bisa bermanfaat bagi kita semua, khususnya para peserta, dan bisa mengaplikasikan apa yang didapat dari kegiatan ini dengan langsung. Mungkin demikian sepatah dua patah dari kami selaku perwakilan dari Balai Penerapan Teknologi Konstruksi. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Salam sejahtera untuk kita semua. Om Swastiastu, nama budaya. Untuk waktu dan tempat kita kembalikan kepada panitia. Kami persilakan. Terima kasih. Yang mungkin Pak Siswanto dapat kami sampaikan.
Terima kasih Pak.
Terima kasih Pak Siswanto.
Okay, Pramon, I think you can start yours.
Okay. So good afternoon all. Can you see my screen and can you hear my voice?
Yes.
Yes.
Okay. So my name is Ramon Steins from Sales Enablement Department from ALLPLAN in Munich. Welcome to this webinar and sincere apologies for the technical problems we encountered. Now it's all good, so now we can start. Yesterday we did a general introduction of the position of ALLPLAN within the Nemetschek, what is the group above ALLPLAN. Will not repeat that, but what I want to do is look a little bit back on what we presented yesterday and give a small outlook on what is coming today and actually tomorrow in the third webinar. So yesterday we saw a presentation of ALLPLAN Engineering, the powerful capabilities of the free-form modeler, the parasolid modeler kern we have inside. We didn't put that much weight on the parametric building elements also included in ALLPLAN, what is used on the building side, because the focus for this webinar series is really on infrastructure. So what we saw were the great capabilities of the free-form modeling and the reinforcement module we have within the software. Today it's all about ALLPLAN Bridge. So the bridge solution we offer to the bridge industry. And that's a more parametric way of modeling. The presenter of yesterday, Stefan Binnemans, will also be the one who presents the bridge solution today. And with that bridge solution, we brought something to the market what was not existing. So it's a real unique solution we can offer. So actually, this is the point that I want to hand over to Stefan, but I think to introduce him again, he's a very experienced ALLPLAN consultant and his focus is on civil engineering, specialty is in bridges. You see Ralph Pullinger also listed on this slide. He will be the one who takes us to the presentation of BIM Plus tomorrow. And he will assist in some workflows also, Stefan. So, Stefan, I give you the control, or maybe Ulrich can do that. And I hope you all have a very pleasant webinar today.
Okay, you can all see my screen?
Yes.
Yes.
Okay, let's start PowerPoint. So today will be a little bit different. Yesterday, I will start with a longer PowerPoint introduction to give you the overview of what the possibilities are of ALLPLAN Bridge for modeling and analysis. It's quite extensive, so it's better to give you an overview with some slides and short movie clips. After that, we will dive into ALLPLAN Bridge and do an introduction of the possibilities, how you work in ALLPLAN Bridge, what the parameters are, what the links are between different elements, and we will do that with the getting started example. The getting started example is included in ALLPLAN Bridge, so it's easy for you to start with, and there's also a manual included. So we'll go through this example. After that, I will start from scratch and show exactly all the steps that you need to go to create your parametric bridge model. And as a last point, I will show you what the update can bring for a finished bridge model. That means you have a parametric model generated in ALLPLAN Bridge. What does it mean in ALLPLAN if you do an update let's say for a visualization purposes where you have a dressed up bridge model? And for this, I will be using a project that we also showed yesterday, the flyover Keres had, just a segment of that bridge. So we'll continue now with the PowerPoint. Just to check, can you see my whole screen? So you also see the ALLPLAN logo at the top right?
Yes, we can, Stefan.
So everything is okay?
Yep.
Yeah. Okay, so first, ALLPLAN Bridge. What is ALLPLAN Bridge exactly? ALLPLAN Bridge is a parametric modeling software where you can do the design, the analysis, and then detailing in the link with ALLPLAN engineering in one solution. So it's a whole portfolio of parametric design into one solution. It's fairly new software. It means it's very exciting because it advances quickly. It was released first version about 2 years ago in April. And at that point, you could do parametric modeling, and each 6 months, there is a new release where they build new functionality. So after 6 months, the second release, they did the parametric tendon modeling. Then they started with construction stages and cross-section calculation. After that, they start with the analysis, so that was last October. And then in April, they did a new big step where they included live loads for your bridge analysis. Of course, there will be a new release with ALLPLAN 21 also in October, and new exciting things will be included. So we see there is a really big improvements or additions going on because it's new software. A lot of things can be added, and it started with modeling, and still modeling is improved. New functionality is added each release, so it's going quite fast. That means if you work with ALLPLAN Bridge a couple of months ago, some new things will be there, and many new things, many exciting things are getting possible also in the near future. When we talk about BIM for bridges, ALLPLAN also is working on including BIM for infrastructure, which is then included in IFC 4.1, if I'm correct. So they're working on that in one of the future releases to implement that. Now, if we talk about BIM for bridges, we could do with ALLPLAN Bridge already the parametric modeling. We have the construction stages that can be generated. So you have some visualization. You can set this up. We'll show this later also. Analysis model. Then we have the analysis results that can be calculated. Also, with the link with ALLPLAN, we can do the reinforcement detailing. And there is one check which now has been included in the -1 release in April, is then the reinforcement design and checks. Okay. Now, for modeling advantages, so when you model, how does this parametric modeling work? Very basically, you have a cross-section, which is the profile or the cross-section of your bridge, and you have an axis, and everything is modeled along this axis, let's say, you can define then variations for your cross section. So you can have a variance. You see here, for example, the bottom of the deck, the cross section is being generated along the axis, but you can set variations for your different variables. So you can control, and this is done in a very nice way. Step by step, you can introduce new complexity to your bridge. You don't have to start with a finalized design. You can start with a very simple cross section and then add variables to it, add variations to it. So you build and gradually get a more complex model as you design it. So you design as you go step by step. So you have full control over it, and it's very transparent also what happens. Some examples we see here, and with this approach, many different types of elements can be generated. So different types of bridges can be generated. Also, piers can be generated. You see here on the right-hand side, so the same principle appears on a vertical axis, where you model with the same cross-section principles and variation principles. So these principles will be carried along the general workflow in ALLPLAN Bridge. So if you understand how this principle works, it's easy to learn also and get deeper into the software. So we have a geometrical model, and from this geometrical model, which is generated by parameters, other things can be derived. You can create a construction sequence from it. You can send it to ALLPLAN and then do some do the final detailing. But it's all based on this parametrical model. You see here that when you change, for example, the axis, your tendons will also be regenerated. So it's something that all parameters are linked together with tables. These variations that you see here, you modify something, the bridge deck will adapt to it. Your analysis result will adapt to it. The geometry that will be sent to ALLPLAN will adapt these changes. So you control fully by these parameters. You can see you can make the deck a little bit wider. You can add a parameter to it, so the width can also be then generated or handled by variations and parameters. Also for other components like a railing and a guardrail, you can add to a bridge deck as an additional component, for example. What is also possible is with a link with ALLPLAN, you can have your library, let's say for bearings, then bearings, lampposts, this is something I will show also in the last example, and you can add them to your bridge deck with the same principle of these variations, where you say, okay, at this point I would like to have a bearing, at this point I would like to have a lamppost. These are parametrically positioned in ALLPLAN. So if you go to, in ALLPLAN Bridge, so if you go to ALLPLAN and then you update your model, you will see that every object that has its origin in ALLPLAN Bridge will also be modified. So for visualization purposes, this is also important. If you change the axis of the bridge, for example, modify anything, then in ALLPLAN, everything that will be added parametrically with this library smart symbols will also be updated. So then you don't need to reposition all these elements, they just are placed by ALLPLAN Bridge. For the tendon generation, so they're based on a grid. So you can define a grid, and each of these points can then be a reference for a tendon. Same principle again, you can control the tendons with these grids and then define how they need to be used with offsets and different settings to the grid. And it's also possible to make this grid follow some variables. So you can say, okay, I just define it and let ALLPLAN Bridge calculate the geometry for the tendon, but you can also say, I will control the tendon geometry by variation tables. So where you control the height definition of the tendon. So here you can see it's just being copied along these tendon grid points. If you change the axis, everything will be regenerated and recalculated. So now there is no need to set any tendon because they follow their parametrical grids. If you have a tendon, then the geometry can be checked, and here you get the losses calculated. So you get a typical diagram where you see the optimal stress being displayed, but also with the slip that you have in the beginning, or if you stress it on both sides, you get different parameter. Again, the loss of the slip is being calculated. So you get from the tendon being stressed for one or both sides, you get a diagram that clearly shows what is happening within it. And this is also automatically calculated. For a cross-section, these cross-sections, they can be generated from scratch. You can also say, create my own library, so you can easily reuse them again. And here you see it's a fairly simple cross-section, but has a lot of parameters. That means all these parameters can be variable. So you can say I have a typical cross-section, but that you can still modify and change to make it possible to have many different types of the same typical cross-section. Also for, let's say, for example, steel cross-sections, there is a possibility to add the stiffeners, and this is a system that can be used also for other types of objects, where you define, let's say, a subcomponent, and the subcomponent can be used and then be placed as a kind of placement, like we saw yesterday, reinforcement. You have an edge and you place it along the edge. Here you can see that you can place any type of object, like a stiffener in this case, along the edge of a boundary with some parameters, so you don't have to define each one individually. It can just populate this edge of this boundary, and then will be generated also in the 3D model, like you see here. So that makes it intuitive and very quick also to model these kinds of things. Here we have two other examples of these possibilities of referencing another cross-section. So for the bridge equipment, like the sidewalks, things like that, this can be typical. You can take them from another cross-section and then insert them in the existing model, also like a barrier. So it's possible to reuse many different things that have been designed before, so you don't need to do this each time again, and you can take these basic components as a part of a cross-section and add them to your existing cross-section. Same thing for girders. Depend what type of girders, steel, concrete elements. You have your cross-section, define it, and then place it, and then if you update one, the other ones will also adapt, and you can then place it in your existing cross-section easily. Also possible for really a complex type of shapes. Yesterday we saw the Tamina bridge. The supporting arc is actually also following this principle, where you have an axis, main road axis, but from the side you can also have additional axis, which is in top view can be a radius here also, and then also from the side view you have another radius. So it's possible to generate objects linked to multiple radius. That means you don't have to define all the parameters, because this could be a parameter where you say this is the main axis, this is a width parameter, but then you need to define all these parameters. It's possible, but you can also say, no, this is just an axis that needs to be followed to the side. So everything, all points here, parametrical points or lines, will be linked to this axis. So this is also something that adds a lot of flexibility for these complex elements. Then we can define construction stages. So if you model your parametrical bridge model, you can then define how it should be constructed. This can be done for modeling only. So if you go to ALLPLAN, then you can see these different elements, and you can create a visualization from it with renderings, for example. Here you can see some kind of flow through the process where the different stages are being animated. Important is these construction stages can also be used for analysis. So if you have a specific construction sequence with tendon stressing, for example, or cantilever, then this can be oh, thank you. Okay, now about the analysis advantages. So ALLPLAN Bridge started with modeling first, then tendons were included, then analysis with the cross-section calculation, and also the overall analysis live loads. So things are being added to make this analysis possible also for tenant geometry. Okay, so this is all in one. When you define your parametrical model, you at the same time, or the same parametrical model will be used for the analysis model. So that means there is no double modeling. You can use the same, the same parameters will be used. You can use the same reference point to define your geometry for your supports on the piers for the abutment. You use the geometry to define the loads, etc. So everything comes from your parametrical model without the need to create a new type of model. For the cross sections, so you have your bridge model, which has its cross section. These are also automatically defined as soon as you calculate all cross section and each variation of the cross section for each point in a station point where there is a variation, the cross section properties will be calculated automatically. Here for the construction sequence calculation, so it's already for modeling that is what this can do, and here you can see then a simulation where also the analysis is being included. So then you can see construction sequence, cantilever direction, and then you can see this forces being displayed. Also possible with this is that you have multiple construction variants. So depending on the design or construction you choose, you can have variants where you can compare with each other. So let's say if you choose one construction sequence or construction variant, you can simulate it, or you can have another one which can have a different order, and then you can compare them with each other. You don't need to create a new model. You can just create alternative or variant construction stages from one model and then compare the results and do some optimizations. We have the superimposed dead load. So when you create a section, you can have in your cross section defined elements which are then the actual member, or you can say these are additional elements which are just generating a load. So it's not part of your structure for the analysis as what defines the strength of your bridge. It's just a load put on top of the bridge. And this is also done when you create the cross section. You can define this element, this barrier is just a load. Yes, and then it will be included also, for example, in your construction sequence where this load will be then set at a specific point in time. You see here, sidewalk, for example, this is just load that will be added to it. In the cross section, there is this coloring code also, like blue is then the general members and the green is then what would be the additional dead loads being added to it. So again, you start from the parametrical model, the geometry, and then for analysis, the same information will be used. Then we have the superposition, so where you do the combination of different cases, and you can add this in an intuitive way, like visual scripting, like where you make these nodes, connect them, and then make combinations that only the worst case state will be used in the final analysis, for example. You can set this up and then reuse this combination or this table or this canvas for other projects also. So you can create some kind of flow charts, how this combination should affect and how they have to be used, and it gives you a very good overview. Presenting of the results, so for the analysis, based on your 3D model, and then you can activate the representation, so you can see a deformation, for example, depending on the different envelopes that you have defined, like a temperature or wind or the sum of the loads, for example. And then you can also define with color coding by the surface or also with some diagrams. You can choose which one you would like to see, what combination you would like to see, if you would like to see multiple of them, one next to the other, and then you get a good overview of this representation. And it's also possible to export this to a table where you see then the result and can export this also to Excel, for example. So many different possibilities for visualization possible, depending on the type of result you would like to see or visualize. Let's go ahead a little bit. So different combinations there. And here you can see that you can do it in a table representation and also send it to Excel. So you have a good overview of these results and can use them somewhere else. So this is the final slide of the PowerPoint. So we have one single model, one single source of truth. And then this means you have your parametrical model defined, generated, created in ALLPLAN Bridge. It can be used for structural analysis. Model is part of it. And you can also use it as a detailing model because this information can be sent to ALLPLAN engineering, where you continue adding information to it, like reinforcement, for example, quantity takeoff visualizations. So the start is the parametrical model that can be used for different purposes. If something changes with the parameters, all models will be updated or can be updated and taken into account this new design or the changes in the design. Okay, that was it for the PowerPoint. Now, next step would be to dive into some examples. So,
Stefan.
Yes, yes.
Is it okay to interrupt you just for a second?
Yes, yes.
We were wondering if you are doing some Q&A at the end.
This is also part of it, yes.
Okay, so Svante will just collect some questions,
Yes,
and
yes.
maybe ask them if we have time enough at the end.
Same format as yesterday.
Okay.
So at the end there will be time, and I think we will have more time today than yesterday for the questions and the final wrap up.
All right. Thank you very much.
Yes.
Sorry
Okay.
for interrupting.
No, it's okay. So when you start ALLPLAN Bridge, so I will dock this again. Yes. You will be greeted with this welcome screen, and there are examples, and this is very interesting if you want to get into the software. There are multiple examples, different types of combinations with different types of designs, and each of them has something integrated where you can experiment with to see how this has been done, some small explanation. And here for this getting starting example, there's also actually a PDF manual included with all the steps to create this from scratch. So if you want to dive into ALLPLAN Bridge, try out something by yourself. This is a very good way to create your first model. It includes many steps, the setup of the parametrical model, and also goes into analysis. So we'll start with this example. And this is a concrete bridge with tendons. So here you can see the bridge model with the color coding for the different types of elements. You can see the tendons also. And I will put this here. Okay. So with the interface, you have the action bar with the different task areas that you have, and you have then a palette where you navigate to different parts of your project or your model. There are different ways to visualize also something depending on the materials that have been defined. You can also say, okay, this is like now we see concrete texture, for example. So there are different ways to set this up. Steel can look differently. So there is also some different visualization possible types possible here. So what do we have here? We can see we have a bridge with two piers. We have tendons. We have actually a different phase. You can see that there is overlapping tendons. So there will be one phase here, another phase. I think there will be 3 phases. So this is just this getting starting example, has everything included. And we can go over the different elements just to see what they mean for ALLPLAN Bridge for the parametrical model. And after that, we will do some step-by-step where we go through how we can create a model like this from scratch. From the design perspective, So we are here in geometry, the structure, similar to what you have structure in ALLPLAN. And we see here the different, let's say, steps or main elements. We have axis definition. So axis is a geometric element. You can see this here in red color. This is the axis. We have to define some cross sections, multiple for the pier, for example, for this one here, for the main girder. We have variations. And here we can define tables. For example, how the height of this bottom of the deck should be varying. Not necessarily this one. You need to have axis cross section, yes, but the variation tables or the variation is something that you can define if you need one. And many of the structural members, this is actually the 3D objects themselves. So you have an axis defined, you have a cross section defined, and with these two together, you generate your 3D model. In this 3D object, let's say main girder box, which is the blue one here in the bottom, you have still all definitions from cross-section and axis. So if I check here, stationing, what is stationing? Typically, the stationing is what you have here. You see 0.5 meters. This is stationing along the axis, not necessarily defined by the axis, because you can, in the main girder itself, you can define, or when you create it, and afterwards also, you can define additional stationing. That means the stationing is not limited to the stationing you have in your axis or in your profile. So it gives enough flexibility to add stations by yourself. So if you check here, the stations, so these are all the stations being used. So you can just add a new station somewhere if you need it. You can also see in light blue where a pier is attached to it, for example. Cross sections, you will see here what actual cross section is used on what station and what variant it generates. Yes, so you get an overview from this is this main girder, and there are many different variations because of the variation tables, different parameters being used. And then at the end, the third one here, you have an overview of all the variations being used. So we have, for example, web width, and then we see that it varies. You have the thickness of the bottom. We have the height of your cross section. Yes, so there are different tables. I will show later where this exactly comes from. But you have the stationing along the axis, you have a cross section which is applied to stationing, and then you can also get the overview of what variation actually is being applied with what value. So you have this table value where you see the actual value being used at this point. For the piers, the same thing. You have a stationing, cross section, variations. Now, if you go a little bit deeper here, with the axis, for example, so we have our axis. How is the axis defined? If I check the axis in plan, then you will see the elements that have built up this axis. So we have a starting point. We have a first segment, which is a line, 15 meters. We have then a spiral, clockwise, with this specific definition. So it starts at 0, and then has a specific length and a parameter at the end, curvature. And then we have here a radius. These are parametrical elements. That means I can change the radius. For example, I will change this now to 200. And then you will see the axis being changed from minus 200 this way to 200 going this way. So it connects still with the other objects. If I regenerate my model, then you will see that everything will be recalculated depending on the elements that you choose to be recalculated. Like at this point, I've also set the analysis model to be recalculated. You can just choose, I just want to see the geometry being calculated because I'm still modeling the geometry and don't want to update the analysis results. Then you can also set this. So here now we see that the bridge has changed. We see that in this case, the axis has changed, but the super elevation at this point is not right because it is for a turn that goes the other way. Okay, you can set this, can have control over all these parameters individually. If you want, you can also link different parameters with each other. Maybe at this point, because I rechecked the analysis model, for the analysis model, we can also go to the results, for example, of the cross section. So here we have the cross section and we have the different variations. And if I check here variation, then you will see this display of the cross section calculation with the different values. Yeah, so you get this here for each different variation. Then you can see clearly also what how the super elevation changes, how the height of the section, cross section at that place changed. So you see it very well, which one you're being used in here in 3D model, and you get the results right here and all the values. Okay. So let's do other update or another check here for the. I'll first generate the geometry again, maybe change the axis back to its original value. So minus 200, for example. Oh, no. Yes, so minus 200, enter, and then we can see this being original situation again. We have the axis, and we at the same time we have the profile. So the profile is along the length of the axis. It's 155 meters. You can set heights. You can also set a point, and then by a tangent or by a radius, you can set also how this curve should be calculated. So at this point, if I check here, you see the rounding type is being applied with a radius to generate this curve. So these stations are actually generated by the profile, and no need to have them here in the axis, for example. Okay, then so we have defined these two elements, axis and profile. Together they form your 3D axis. Okay, so I will do finalization with analysis result. Then we will go into some analysis display, like you've seen in the PowerPoint. And after that, I will continue with changing some modeling parameters, where we change, for example, in the cross section, the main girder box, see what parameters define it, height, for example, super elevation, and then we'll take a look at the variations and how exactly they work to control these elements. So if you check the results, for example, you can choose to highlight different combinations. So let's see if I have my analysis model. There, yes, okay. So we have 3D model, analysis model. So depending on what you choose here, what combination you choose, you will get a different part of your model and different visualization. So for example, if we check, for example, here in the bottom, I would like to see for the wind loads, for example, wind, different types of combinations have been set here without traffic, with traffic, for example. So we can highlight it. I don't want to see the diagrams, for example. I would like to see the deformed structure, and then you choose here what case you would like to have, and then you can visualize these different parts. Okay, so if I go up again to, so we have here with the tendons, temperature, braking, wind, so different types of elements that you can visualize. And here you can choose then what load cases you would like to see, for example. And then depending on the diagram you activate, you will see some different element. Yes, so you have full control over the different parts, and you can just activate which one you would like to see. Okay, so here you can see, for example, the deformation also being set. You can play with these values to see exactly how it's represented. And then you can see, for example, I don't want to see these diagrams, for example. You just want to see the deformation type for wind, for example. So you can choose what elements you would like to see, how you would like to visualize it to give you a good impression of the things that will be happening in your model, and compare the analysis results. Okay, so let's go back to the 3D model here, the geometry. So we've seen axis and plan. Yes, and then next step would be taking a look at the cross section. So in this cross section, main girder box, you can choose any type of name you would like. And here we have all the different elements that are defined in the cross section. So we have our main girder, we have then the additional elements being added to it, like a barrier, for example, which are not part of the structural element. Everything is defined by reference points and parametrical lines. So you see here these gray lines, parametrical lines. What does that mean? It's how I can control how this section behaves. For example, the one here in the bottom, if I click on it, you can see possibilities, and I will change the distance. And now if you change the distance, you see what happens here. The web on the side, they will be just keep its own orientation, but the main girder will become higher. So the cross section will become higher. But if you see also in the bottom will become actually smaller or less wide because of the angle of the web is fixed. So you can define this also how the different elements should behave. If I click another line, then here you will see now that the thickness of the bottom can be controlled. But that also the chamfer that you have on the right hand side, this one here, it just follows web and the bottom of the deck. Yes, so everything can be linked with each other. So this is the definition of this parametric lines. You have a line, you can set it to parameter, and you can link another line to each one. So again, if I change this one here, you can see the bottom thickness doesn't change. It just follows this main line. That means this one is linked, and you can see it in the preview also. This line is linked to this line. And we see also that this line is linked to the main reference line, which is through the axis. So that means if the bridge goes up and down, this will follow, of course. Other example here is the inclination, for example. So I check here this line, and then you can see that I can change the angle, and now I have control over the super elevation of the deck. And what is special here, this part where you have the barrier is not influenced by it. It has a fixed angle. So if I go to this side, you can see it's all the other part of the deck will change, but this one has a fixed angle. So again, you can define a relation between a line, which will probably be through this point, with a fixed angle in this case, and this follows this point. So if this moves up, this angle stays fixed, but will move up also. So in the cross section, you have different types of parametric lines that you can create. Just a parallel line through points with an angle or with a relative angle linked to two different lines. So many possibilities to define how these lines should behave. Next to that, we have the reference points. Reference points can be used, for example, here to put a bearing. This could be a bearing, or it could be a connection with a pier. It could be a lamppost. So you can add reference points to it that can be used for smart placement. And you can also see that the analysis model is being included here with the other colored lines. This is a grid, a point grid, and this is used for the tendons. So if you access a point grid, you can still access the parameters here. So for example, I have a row of 7 or 2 rows, sorry, you can see here 2 rows, and then in the other direction I have 7, so you can still control, okay, the spacing should be different, or the spacing should even be controlled by a variable. Yeah, so let's say I want to here just have 5, for example, then you see you can change this to 5. If I update my model, this change will of course be applied to my geometry. So cross-section, main principle, you have your parametrical lines and reference points. You define then a boundary which uses some of these points, and the relation between the parametrical lines will then be kept and will define how your cross-section will variate. So we see here, this is linked to a variable, and I would like to move this part somewhere down. Yes. So you see here that this is linked to a parameter, height of the section. So what does this mean? I can define in my main girder a height of the section, or the name that you can give, doesn't matter how you name it, height of the section, which has its own, let's say, default value. And then when you assign it, or when you assign this variable to a parametric line, you just do this also here. You can say, okay, it shouldn't be assigned to any, or it should be assigned to the height of section variable. That means you can control it now outside of your cross section. If there is no variable set, then it's just a fixed line. You can modify it here, but you cannot control it. So this is important when you design and get more detail, more depth to your model, that you will be adding variables to it. You don't need to have it, then you get a fixed model which doesn't vary along the axis, for example, but you can still modify it here. So if we check again the main girder box and the variations, so we are in main girder box cross section. This is the girder. So if you check the cross sections, we see here again which cross section is applied with the variance and variation. Then we can see what variables from the cross section are actually being used in this 3D model. So here we see height of the section, which just comes from the cross section. Actually, each one of them will be visible here. So you see web width, half, bottom thickness. These are all variables coming from your cross section. So if you generate it in a cross section, this will be automatically added to the tables here. You don't need to do anything. It's automatically done. What you have to do, or what you can do, is define how the variables will be used. So here you can see this different values, like the default was for something 4 meters, but now you can see actually there is a lot of differences. We can see this also in the 3D model. This is the default height, let's say. This is fixed, but then we have some variation. Where does this variation come from? How can I control this variation? We can see here that this the values are being changed. So how actually can you do this? You can just set this right here. I can say this should be 5 meters, for example. 5 meters, I can apply, and then everything will be 5 meters high. Okay, let's say this should be 3 meters, for example. Everything should be 3 meters, apply. And then if I regenerate my 3D model, we will now check, turn off the analysis calculation. So that's okay, then need to wait just a couple of seconds longer. Then you will see that the bottom will now always be 3 meters. So you can control these variables just in this table with a fixed value. But when you have many different variables, it's not so interesting to do a fixed value. For each one, you can enter all cells and then put some numbers in there. You want to be able to control it differently. So here we can see now this model here is being generated like this. Okay, so let's check these variations. Everything is 3 meters. Yes, not within how it should be. So how can I control it? This is done with the variations tables. So again, the link, you have a cross section, which with parametric lines, you can set variables to assign variables to the parametric lines. They will be used in your cross section. You can just enter them as a table and just put the values by yourself. Or what's more interesting, the next step would be then to create a variation table or formula, in this case, a table. So if I would check this, height of section, then we see here that we have this type of construction, this type of variation for the bottom of the cross section. It means the height of the section. So by station along the axis, you see 0 to 155, you get the different heights, 3.7, 5.2. So from this point to this point, 3.7 meters. And then from where you have the pier, you have 5.2 meters. So you see here how it's generated. You see also which type of transition is used, linear or parabolic. So this table with the graphical representation that you clearly see how it will behave, I can assign to my variations in the cross section. So you can say, okay, I just added to one cell, for example, let's say this one here, and then it will be calculated. You see this jumps to 5.2, or I can apply it to just drag and drop it on top of the column header, and then you will see now this will be generated, and all the heights corresponding to the stations will be calculated. So you don't need to define each station individually. Just from this station to this station, this type of transition will be used, linear, parabolic from there to there, and then all these values are calculated. If you add a point to it, a station to it, it will be automatically calculated what value it will be depending or corresponding with the variation table. So if I now will not forget to turn off these things here. I think this is enough to just turn off that one. And then if I regenerate, then my 3D model will be generated. And now it should be the original state again, where we have the deck bottom corresponding then on connecting with the piers again here. So now we have this height setting. So let's say if you want to adapt something, this can be done in this variation table. And let's say this should now be, and I will exaggerate a little bit so we can see the difference. This should be 8 meters. So you can just assign the value to it. This will be adapted. The variation also will be adapted as soon as you regenerate. Everything will, so the tables will adapt and the 3D model will adapt also. So let's say regenerate. Now the model will be recalculated and will include, so now you see here 8 will include this variation that this is now changed. This is what is done internally. What is also interesting is that ALLPLAN Bridge has an open interface by going through a TCL file. And this is a text format that you can read and you can just modify it. So if you want to have external access to this file, you can just say, I will save this project here. And so this is, let's say, 01. And I will also open it, this file, with a text editor. And then you have all the descriptions here from the axis, from the cross-section, from the variations described in this text file here. So you see, okay, this is the axis, profile being described, and here we have already the variation. So the height of the section, we see this is this 8. So I can change this in a text file and put this again to 5.2, for example. So that means you can copy paste thing from other software. You can also play in this table to do some, or in this text file to do some optimizations, for example. Okay, so save the file, no need it anymore. And now I can import it. So remember, this is this 8 meter. Can import it, this file again. So just modify it externally. Do I want to regenerate and overwrite? Yes. And now my 3D model will be, or the full model will be regenerated. And now you can see again that this is the correct height. So this can be an interesting case where you have this open interface that you can use to change the values and adapt some elements of it without, or just by accessing a text file. Okay, about the tendons here. So we have the tendon generation. We saw in the cross section that there is the tendon grid, a point grid here, and the tendons are used. And when you define the tendons, you can choose what point will be used. So let's take a look at that. We have this tendons here. You can see that actually it seems there are redundant points, but this is because you have different stages and you also have tendons which are then overlapping. So probably stage 1 goes there, where you have the end of these tendons here, and then you have another where the tendons are already embedded in the structure for the next stage. Yes, so these tendons are then defined on the points, and because you have multiple points, you can just choose which one you would like to have there, and then you have enough space for the other tendons to go in between. So it can also be generated or controlled by parameters if you need more distance to it. I think we will see this here. Like at the start, they will be, or here in the middle, they will be very close together, and here where you have this multiple tendons connect together, you have a bigger distance between them. This is also controlled by the variation tables. So you can define a tendon in different ways. You can set it through points without having the points varying, but here you can see the points, there is some variation going on with the height of the tendons, with probably the distance between them in 2 directions, and this is what we've set here as a variation table. So check the tendon height, for example, and then you see the evolution of the tendon within the main girder, the deck. So at station 0, this is the height. And then it goes to 3 meter, for example, 3.16. So depending on where you have the piers, so you will have this tendon height being variable like this. So this is something that you can get from a calculation, for example, and input the values there. This is the spacing in the height, and then you see again along the length of the bridge that the spacing horizontally at the start, of course, where you need to have the anchors, the spacing is a little bit wider, and then the parts where there is no connection, no anchors needed, it's closer together. And the same thing for the spacing vertically. So vertically, we have this 0.2 spacing, and then 10 centimeters, let's say in the bottom of the deck where there is no interaction with other tendons, and then above the piers, you have again more spacing, so there's more space between the tendons also. So this is what you can control. So these variables, they control the tendon grid. So same principle, if you check again the section, like you had with the parametrical lines, same principle is here with the point grid. You can see the offset here, or spacing, is defined by spacing horizontal, and spacing here is controlled by spacing vertical. And then the offset that we have here, there is no offset horizontally, but there is an offset vertically. So this is the height of the tendon grid, where it's positioned so that it flows along the 3D model from the start to the end. Yeah, so same principles of the parameters and the variations that you can set. You can start with a very simple cross-section and add to it for the geometry, add to it for the tendon grid, and then add variation tables to see how they will be controlled. Now let's dive into one of these tendons. Here you would like to have, like maybe depending on what kind of construction you want, do they need to be stressed? At what point do they need to be stressed? Do you need to have blisters or a wall where this web would be thicker, so the tendon will be outside of the wall a little bit, so you can still have access to the anchor and stuff. This is what we will check now. So for the tendons, let's say, so you also have different phases. For the stressing and stuff, they will be, let's just go in the modeling of the tendons here. So we have the view of the tendon model, where for each tendon, let's take this one, for example, here. So you see this tendon being highlighted, and you can see also its parameters. So at this station, which grid point it uses, you can see it here in the cross section, and then you can go through the different sets. So if I look from the side, for example, and then you will see that it jumps from one point to the other point. So for each segment, and then you can check here where it's located, and here also, and then so you can see it going through these points, and this is what the tendon will follow. You can still interact with these points, so you can even change the grid point, that reference point that the tendon uses. If you want to switch it from there to there, you still have full control over it at the end. An example that I want to show here is for this tendon that we have here in the middle, for example. And I will zoom in on this number 4 or 5. So this tendon here at the top. I'll zoom in a little bit. So we see this, this tendon here. And then I want to see it, so where it will be then going on the inside of the wall. So we see here it's still inside of the web. And I would like to be here to jump a little bit on the inside. So what point do I need? I can check here from the station point. You can see here this is this point, and now I can change a value where it should deviate from its position defined by the grid. So let's say this should now, and I always forget it's plus or minus, so 1 meter to the side, and then you can see here it will be located there. If I regenerate, maybe this is a little bit too much. Let's say 0.5, can recalculate. And, oh, sorry, there's a wrong recalculate. Then you will see it being generated. So here you can see now that the tendon is positioned there. I wanted to show it right here in the tendon geometry definition. So there you can see also that it's now being positioned like this. It will still follow the grid. It's just that there is now an offset to define. So no need to define this in the beginning. You can change this afterwards depending on information that you gain, like anchor type or whatever you need to be able to construct them to see this also in a detailed model. So you have full control over all these things, all elements and all parameters. Okay, I think this is enough here. Maybe is there some result for the tendon that I can show? If I select a PDF document, be generated. I'm not sure if I did the analysis. So here you have then the overview of the tenon definition, and you can also see then where it's how it's being generated inside of so like a table and a schematic of this tenon. Same thing that I showed in the PowerPoint. Also for the tenon losses can also be generated. Okay, I think this is it for the overview of the geometry. Maybe Siswanto, if there are some questions here, I can go deeper a little bit into this model for the geometry. If not,
Yes.
I will jump to ALLPLAN now to see.
Yes.
Questions?
Yes, there is a question for the super elevation.
Yes.
Can it be designed in ALLPLAN Bridge? Let's say you know that when you turn, you have a certain super elevation that you need to put, right? Is it something that we can be designed in the ALLPLAN Bridge or in different application?
And you mean the value should be calculated?
Yes. The value?
No.
Right? Okay.
No, because I input the value in ALLPLAN Bridge. That means I can design something which is or over design something or under design something. This is up to you. Because if you want to have the super elevation, then you need to have, for example, the speed set, the type of vehicle set, the surface set. This is not something you calculate, if I'm correct, in ALLPLAN Bridge, what super elevation it should be. You can just define the super elevation in any way that you would like. So if somebody does the calculation, they say we need to have 3% here or 5% or 10%, then you just input the values here and the model will be generated depending on these values.
Can you show
Yes?
how to create the super elevation in just this model?
Yes, yes. Yes. So what you need for this is that you don't have to do this in the beginning. You can add this later, but you need to have a definition of a parametrical line which defines the inclination or the super elevation. So in this case, this is implemented, and you can see here, this would be the line that defines or that makes it possible to define the super elevation. Yes, so you can see this is the line that can rotate or let's say change the inclination. There is also parameter set to it. So if you check here, we can see this is the inclination. And you can say, okay, it should be a fixed inclination here. Doesn't matter too much right now. This is just a definition. What is more important is that when you have the inclination, that you can control it through this variation here. So now we said we have an inclination. I think this is then in degrees here, where it starts at your station 0, where you would have this value, at 15 meters this value, 8 meters this value, so it just goes from this value to the end. And this is then what we will see in the 3D model. But that means if you change the axis, you should also adapt this. So here we have the super elevation right now. Let's say I will set everything to 0. So we check here. So this one should be 0, this one should be 0, this one should be 0. And of course, I can add new stations to it. Yes. So everything should be 0. If I regenerate now, then the super elevation, or there will be no super elevation. You see now everything is just flat from start to end. And then you can say, okay, I will change the inclination again and say at the beginning I would like to have -2, -2. And it should go to -8 or something, -8. Oh, something like this. So you can control with the different values at any point. So the thing is that you will need to add the station points. Mostly these are not too many, like you have a straight line, you have a clockwise or a spiral, and you have a circle. And then for these points, you need to set how the super elevation will change, but you have full control over it. So it can be on a straight line, for example, you can change from minus to plus. It's just that you need to input these values here. And then if you regenerate now, the model will take into account the super elevation that I've set. So you see here now, this is -2. On the other side also, this is a little bit more, this is -5. Everything will be regenerated. So it's just a question of adding the right value to the table. But it's user controlled. So user has control over this. If he wants to input a negative or in the wrong way, super elevation, this is possible. Yeah? So it's up to him to define the right values here. That's the answer to the question?
Yes. Can you show, is it possible to show how to import LAN XML, let's say, into the Allplan Bridge?
This will be shown tomorrow.
Oh, this will be shown tomorrow.
I can quickly, yes, can quickly show how you would do it, but I will not do it because then I will need to generate a model, but we have this prepared for tomorrow. So this is done by BIM Plus. So if you log into BIM Plus, okay, then you can get access to a project. So you choose a project, and this is then the BIM Plus interface, which shows you have access to your projects in your teams, different teams, and then you can choose the one that you would like to use for alignment. I'm not sure if there is an alignment here, so you just pick a project, and then you can say, I would like to import the access. And then you choose access, and you see here there is a model and there is no access here. So you need to have an access to be imported. So the thing is, this is generated in BIM Plus. Somebody uploads the access in BIM Plus. You connect here to the download it, and then it will be used. The horizontal, the access in plan and the profile will be used. You can have multiple access that you import, and they can also be updated. So if the model updates, the new revision of the access included, you can also update it in BIM Plus. In Allplan Bridge. So the link is done here through the BIM Plus. Yes. So this will be shown tomorrow.
Okay. Jadi menjawab pertanyaan untuk LAN XML itu bisa dilakukan di Allplan BIM Plus. Besok akan ditunjukkan oleh Mr. Stevens. Stevens?
Yes.
Can we use Allplan Bridge to design runway, taxiway of the airport? I don't think so, yeah?
What do you mean with taxiway?
I think in the airport, you know that there is a runway, right? Like a road, yeah?
Yes. Yes.
Is it possible?
And then what you would like to see for that? Oh, taxi, you mean for the airplanes?
Yes, airplanes.
I thought you mean taxi for people picking you up at the airport, but it's taxiing for the airplanes.
Yes.
I would say if it's in general, it's just a big slab of concrete with some access to it. I would say yes.
Okay, so it's possible.
Yeah.
Okay.
Yes.
One other thing before you go to the next stage. Can you are you able or will you show a cable state bridge sample? Because I see last time you showed me a cable state, yeah?
I can show an example.
You want to show an example, or you want to show some example of the model that you did before?
I will show one model of the one model I did before. Some examples. I have 2 or 3 examples prepared that I would like to show after this here.
Okay, no problem. Go ahead.
Okay. That's it, right?
Yep.
So I will be going through a real step-by-step. So this is, let's say, a model where there is already quite a lot of detail included, and I will go step-by-step to where we start really from scratch with an access definition, with the cross-section definitions, adding some variation to it. This will be in 15 minutes or something. Okay, so let's go to some examples. Oh, no, sorry. I want to show, of course, first also for this example that we have here, the link with Allplan. I will show in the end of the presentation actually the live link where we model something in Allplan Bridge or have a model in Allplan linked with Allplan Bridge, modified in Allplan Bridge, show it again in Allplan. But here I would just like to use this model and then see what we can do with this model in Allplan. Okay, so this is the same model that we see here, imported from Allplan Bridge. And what is interesting is that you have control over what kind of elements you import. So you can import, for example, just the main elements, main girder, the piers, like this side elements also. Construction stages can be imported. So these are things that you can then handle in Allplan to create visualizations or drawings, etc. But what I'd like to show here is, remember yesterday, there was the sweep functionality that I've shown, and it uses edges. Now, what is interesting from Allplan Bridge, you can see these lines. These are actually the edges being generated in the Allplan Bridge model. So they can be transferred. If you prefer, or there's a setting, you can transfer them to ALLPLAN and you can use them to create your rebar. So when you generate a complex double curved model in ALLPLAN, in ALLPLAN Bridge, you don't need to define these edges by yourself. They are just transferred, so that makes it efficient to reuse them for your, let's say, typical reinforcement in that section. So I have here a section for the bridge. I will just define a bar shape, not a realistic one. It's just to show the impact of these or how you can control these edges. So I just say I will create it here in this section. And right now you see it will follow this edge. So here at the top, this edge, this one in the bottom here, and then this one also in the bottom here. So we'll see this variation going in height, in width, because it's getting a little bit thinner here at the bottom, and so follow also the orientation of the web and become then higher here above the pier. So we have a lot of variations, and it's double curved also the axis. So we will use this same sweep as yesterday, sweep bars along. So choose the bar, and now have to choose the axis from generated by ALLPLAN Bridge. So the main path is the main sweep here, is the 3D spline. This is then the axis. And now I will use the secondary or the other parts to define the geometry. So this one here, you can see that it will go from the start to the end. So in ALLPLAN Bridge, this is segmented, but you can select it easily all at the same time. So select this one here, you can see the top, do the same thing for the one in the bottom, and then you can see that it goes, follows the bottom curve, and here the edge on the side also for this one. And then you can see this is also following this curve. So now I will create a 3D reinforcement along this axis and following this definition of the edges. So, okay, let's say change so this is now 1 meter, it should be 0.5 meter, for example, and then you can see here that this is now everything adapts quickly to it. So you see it follows the edge here follows nicely the side, it follows here the bottom. Yeah, so we'll make this a little bit bigger. So with just a couple of clicks, you reuse the geometry definition from ALLPLAN Bridge to create reinforcement in it by just clicking the edges. Okay, now let's go to the examples. First one would be this cable state. So yeah, by coincidence maybe. This is another real bridge. It's just a design based on existing bridge that has been reproduced in ALLPLAN. So what you see here, actually, everything that you see here is generated from ALLPLAN Bridge except for the water surface. This was just something in ALLPLAN. But what you see here is you have the rail, the railing, handrail, you have the cables, you have lampposts, you have vehicles. Everything is generated from ALLPLAN Bridge. Yeah, with this smart placement. So it can be quite detailed. And it's parametrically designed. Yeah, I will now show this in ALLPLAN Bridge. So open, see if I have the project ready for it. I will get just the TCL. So import TCL. And so let's say, yes, open the TCL. Now we have this model here. So what I would like to show here also is, or maybe the different parts. What you see here are multiple axes. So I have a main axis for the bridge. I have one for the bottom to define the positioning of the piers, I think. And I have a secondary axis. And imagine in this case, you have your fully detailed bridge, which can take some time, but then there is a modification in the axis, or there is a variant axis, which is also interesting because you just don't want to modify the axis. Maybe there are two positions where this bridge could be created with two different axes. And then I can modify this to be able to, so here we can see there are two axes, main axis 1, axis 2, and this is the bottom. And let's say I would like to have everything being moved to the other axis. So my girder, oh, this is the people placement. So you see there is, in Allplan, you could see there is like this person object being placed along the bridge. So this is with a variation, the train, the lamppost and stuff. So there are different elements in Allplan Bridge, which, so you see all these black dots. These are actually the smart placements. So maybe I can go into detail a little bit. This is the handrail, for example. Then you see in the variation that there is a handrail, and this is where the handrail is positioned. So every station there is a handrail positioned. For example, if we take a look at the lamppost, then we will see lamppost or the persons. Yeah, so here you can see where where they are defined. Yeah, so again, controlled by a table. Now let's just see here what happens with everything has been defined, like the main girder, the piers, the cables. If I change the axis, so I have here my different elements. So just select everything. You can see here girder 1 is linked to axis, so I can choose a different reference axis. I will select everything except, oh, I will select everything here. It should be to reference axis 2. And the foundation should then be linked to this one in the bottom. Okay, so now if I regenerate, the model will be regenerated along the other axis here. So by just setting, and everything will be recalculated. So all positions will be regenerated, like all the position of the cables, this handrails. So we can see that the axis is different if we look from the top. So let's say the start is similar, but this is straight and this one goes to the right, and then another side again, but everything follows nicely. Yeah, so can quickly change this again. Let's set everything again to the axis 1, variant 1, and then the different elements, variant 1, regenerate. And then you see it now, oh, sorry, it's being regenerated again on the original position. Oh, didn't work. Like this, yes. So this is something that can be easily done. Okay, let's go to another example. There.
Go ahead.
Also same, yes?
Okay, one thing before, there is a question. When you create grids in Allplan grids, you already create segmented, but when you import to Allplan engineering, it becoming one. Yeah? Is there any way that you can make it more easier to be exactly as what you model in Allplan bridge?
So there is the difference, let's say, between a general model and what you would like to see in Allplan would be then construction stages. And if you define construction stages in Allplan Bridge, maybe go back to the original model examples, or maybe I will just take another example. So if you go back to the construction stages, there you define how the element will be split in different segments. So we have another example here. Let's take a look at the construction stages. So you see there are different constructions here, different phases. Oh, and that was not the right one, construction here. So if we have these different phases, and each phase will be a different object in Allplan. So this could be a way to split it. If not, then it will just be one main girder. If you do it by these construction stages, then this will be split. So I will now say, okay, we play here the full construction. And then you will see the pier being generated. Maybe I can make it a little bit quicker here. So this is one segment. This is another segment. So each stage will be, each object will be its own element in Allplan. So this is a possibility, and then we will jump to the deck. So here also you see a pause, maybe a little bit more pause. So this object here, this will now be one segment because it has been defined in the construction stages that this will be like one pore. So I would say the construction stages for the modeling detail is where you define how the different segments will be created. Or this is one way. Yes? Okay, go to the next example. Same thing. This is not real bridge. It's based on an existing design of bridge and then just remodeled in Allplan Bridge to visualize it. So here you can see this is about 800 meters long. Looks a little bit like elevated highways that we see a lot in Indonesia. Maybe same size and span is like 130 meters or thing. I think that is similar to what I've seen. You have these special piers with the variables. You have also the variables here in the variation of the deck height. So if I would open this here, okay. So then you get this model here in Allplan Bridge, where you just have a cross-section defined, main cross-section of the bridge, for example, where it's like double deck or two girders, but can be actually constructed as in one sweep because the axis could be the same at this point. And for the piers, we have a couple of cross-section because there is some variation going on. So if you check here, there is a variation. Maybe I can turn on this here so you can see it maybe a little bit more clearer. So there is a part where this is closed. There's a part where this is open, and then there is a part where you have another type. So this is one pier generated, but with different cross sections. So if you check the pier in the bottom, that would be this cross section. Yes, here in the bottom. Then we have the pier at the top. So that would be this cross section that we have here, where it's split. And then we have a third variant cross section where actually this is also split on this side. And then again, depending on the parameter that you use, not sure which one it is here, then you can control, for example, here also the angle. And depending on how you set this, you can see here at the top, all 4 edges have this, but you can also say when you define one here that all 8 edges will follow this angle. So there are multiple ways to define how the geometry should react to it. Okay, let's go to a step-by-step example. Okay. So I will create a new, I will maybe first show the example step-by-step. Open, so it's this one here. It's very simple, but allows me to show all the different steps. So something like this, where we have one main girder, not too complex, with one pier, and then we will add variation or detail to it. So we'll just start with a new, let's say, project. So there, new project, okay. And then we have our steps that we discussed before. So to be able to generate something, I need to have an axis. You can define your own axis or import from a project where the axis has been uploaded in BIM+. So we'll start from scratch here. Axis, create new axis. Axis 1, you can define the name. Yeah. And now I will define axis in plan. So in the action bar, I go to axis. This is my starting point, okay. And I will now define the first element, which would be an arc. And then you see you have the parameters, length, let's say 35, and radius 300 meters. So first segment will be generated. Okay, then you can say, I would like to have another segment. In this case, I would like to add a spiral with a specific curvature. So the radius, or 1 divided by the radius in the beginning, and at the end is 0 because it will connect with a straight line, and the length will be 40 meters. And then I will add a straight line to it, and this will be then 35 meters length. So this is part 1. I need to have a profile because I need to have a 3D axis. This is just a 2D axis. So I will make a profile. profile. So first point, zero height, not necessarily to set anything. And then I will take the second point. Will be then, let's say, in the center. So the deck is 110 meters long, so 55, and the height will be 1.5 meters. And I will not set any radius right now. I will just add points to the end. So okay, then we would have an axis like this. So let's check this in a 3D model. If we get axis, then you see this is like it's curved, but it has from the side, of course, this gap that I don't want to have here, or this gap, this steep angle, so not a smooth connection where you have one going to the other. So I need to modify this, and you can do this while you create this, or you can easily modify this afterwards also. So you can choose here. I have a rounding type, let's say intersection of tangents, and I will define now a radius of 1,200 meters, for example. And then you see the radius being generated. You see also station points. They will be added to the axis, so you can easily recognize them. So here you see now the axis. Yes, so it's now smoother here also at the top. So this is step one. Now I need to define a cross-section. Cross-section, new cross-section, name, define anything. And now I will create here cross-section with parametric lines. Nothing special, just starting by the main width of the deck, let's say 4 meters to the left, and also here from the main reference point 4 meters to the right. So this is the width of the deck, and let's say I have deck thickness at the top from 0.25 meters, and from the bottom, and now it gets interesting because I can define what should be the distance. Let's say if I choose, and maybe I can just show how it works here, I will choose, let's say, a height from 1.65 meters for the deck, and I will continue a little bit, and then I will show how this relation is being set. So width of the girder in the bottom, 2.2 meters, something like this. So now we have an outline already, and I can define now a boundary. So boundary, just click the points that you need to have. Boundary, okay. This is a boundary. To be able to generate something, I need to make it a structural unit. So in this case, I say this is my reference point and this is the boundary, and then you will see it being filled with blue. That means structural unit. The other one would be a load unit, that would be green, and like for the sidewalks, for example. Now, if we change this, just click, and then we can see how it reacts. So we see the bottom can change. What happens now if I change the thickness of the top slab? So you see the bottom will go down also. I'm not sure if this is how it should be. This is something you can still control afterwards. I can choose here that my reference line should be different. I want my reference line to be the actual main reference line. That means if I change this right now, okay, this still works fine. But if I would change the thickness of the top slab, this will have no effect on my bottom. So this is something you can choose. You can choose the relation between the elements. If this needs to be linked, then certainly you can do this. I would say in this case, it's not necessary. Maybe I can change the value here to 1.9 meters, just for representations purposes. So this would be the fixed distance that I set here. And maybe later when I introduce a bottom slab, I would like to have the bottom slab following this line and not the top line. So these are things that I can play with. So right now we have the cross section. For our 3D model to be actually show something here, we need to assign the cross section to the axis. So for this we create a girder. So new girder, name anything, main girder. Choose the cross section, and then you see here the preview, and you can choose from what station. You can just click a point, and then the one that you click will be highlighted, and you can enter the value here. So this is station 1. Oh, sorry, first cross section, but 0. And now you can go to the end, and then you can also enter this value. So if you want to have another station point, you can just click anywhere and just write the value there. And now we can choose the steps. So step would be that there is a segment, or let's say station created each 5 meters. You can add stations later. You can do it in one step, or yeah, let's do it just now. This is fine. And then the 3D model will be generated here. And now you see we have our, for each 5 meters, we have a station to the end. Yes, there are also some different ways to visualize what you see in this 3D window, what type of elements you would like to see, for example. Okay, I see here that something I forgot to mention in my presentation. The traffic can also be, since the April release, if I'm correct, live loads are included. So you can have your bridge deck, and then lanes can be defined automatically, or by saying what width you should have. You can create these vehicle trains or load trains where you assign them to these lanes to have this dynamic calculation. Sorry, I forgot to mention that. Okay, so let's continue here with the giving more depth to the geometry. So the axis is okay. We have now our section, main girder, but I don't want it to be a closed section. It should be an open section. So you can still modify all these things. So go to the section here, and I would like to add now some, again, boundary lines or parametrical lines. So 0.35, this one here, 0.35. And here from the bottom, maybe 0.3. So now it's important that I choose the right line. If I set the bottom edge coming with a relation to this one, that means it will not follow the bottom of the height of the section. So 0.3, that means as soon as this changes, you see the other line will follow this line. So now I can create an additional boundary on this point, for example, like this, okay. And then I can do also Boolean operations, like we've seen yesterday with the modeling in Allplan, just in this cross section. So the main cross section minus this boundary, and now I get an open girder. So if you regenerate, then you will now have this open element. So very quick to modify something, very easy to go from an initial design and then add detail to it. I think this is really the power also of this parametric design. You start with something very basic, and then you add information to it. As soon as you know, or as the design evolves, you add more detail to your design, or to your cross section, with the variations, things like that. So, okay, let's continue maybe here with a pier. So I create a new cross section, and I will call this pier. And this will be also simple. Let's say I have, again, 2.2 meters in one direction, 2.2 meters in the other direction, and a width or thickness of the pier, 1 meter, 1 meter, and create a boundary. Okay, just go over the points, and then select that this is also a structural unit. Okay. Now, before I can assign the pier needs to have a reference point, and the pier will be attached. In this case, the top of the pier will be attached, can be with an offset to the bottom of my deck somewhere. Let's say in the middle I have one, so that would be in 55. If I would like to add it here, I need to have reference points to make the link between the pier and the cross section. So in this section, main section of the girder, I need to add reference points. So reference points can be used for tenons, can be used for smart placement in Allplan to put a lamppost or a bearing, for example, and can be used to make a connection with another element in Allplan Bridge. So place your reference points at the center, P1, pier, name, you can change this name also. Oh, there was one too many. So you can change this here, also point. So this reference point, one, you can change it. It should be placement in Allplan. You can define this right here. So now I will regenerate a 3D model, and then you can see now there is this reference point, and this can be used then for the generation or the link of the pier with this station. So we'll create a pier, new pier, select the reference point. So select this reference point here, And now you can choose, similar to the cross section, your section. And let's just click somewhere. And here I will say I want to have it with 0 would be then the reference point at minus 0.5 or something. So that gives me a half meter for a bearing, for example. Can be less, can be more, can be 0 if you want it to be. Okay. And then the bottom, let's say, will be, so I just click somewhere and I would like it to be 50 meters and with steps of each 3 meters. So that won't have something like 5 steps. So here we have the different steps. So we have now a pier, very simple, and a bridge deck. And this pier is linked to the deck. So if anything changes, that would also have influence on my element. So let's go back maybe to the axis. Let's say this one should not be 300 meters, but should be minus 300 meters. So just going the other way. If I regenerate now my model, we should see that this goes the other way, and also then the pier should also follow. Yeah, so this is this parametric definition and the link between the different elements. Okay, so let's change the axis again. So this works for the horizontal axis, the vertical axis. So you can go always back to your initial design. The first element you created can be still handled parametrically and will have effect on the other things that you do. Okay, now next step would be this variation. So the height of the deck. Height of the deck. In the section, I need to add a parameter. So let's first add this variable to it. So it's the length, and let's say this is just height of the section. And now I can define this to this line. So if I don't add it to anything, it will not be used, but now I will add it to this line. You see now something strange happens because the main value was 0. So I just set it to 1.9 again, regenerate, and then this is now main height 1.9 and taken over from this parameter. As soon as I regenerate my model, nothing will happen here because of course it's still a fixed value. If I check the variation tables, then you will have this value right now. And now this is what I've shown also in the beginning. You can do this manually now. Set any values to it. Here it should be, let's say I will exaggerate a little bit, should be 5 meters. And then you can generate it, and then we will see that we will get a model that is something like this. Yeah, strange, not correct, but you can have control over these values just by adding one parameter to the section. So this is now the height, and then I put this to this 8 meters. This is not what I want. I would like to generate it, and I would like to also make sure that here I have something additionally. The pier is not like, oh, sorry, the connection with the pier is not like this one point. It has a flat surface or fairly flat surface to make the connection with the pier and the bearings. So I will add now additional stations to this point. So in the main girder, I will say I need the station at 52.5 meters and another one at 57.5 meters. So that means if I check here, you will now have the 2 more stations added to it. They're not yet used because I didn't define the parameter yet, but now you can see you have an additional station, so no need to assign them from the axis, or when you generate it, you can just add them whenever you model something. And here I will now define the, let's say, a variation table. So a new table for the height of this section. And the height of the section is defined by setting. So X is then the length or the station point along the axis, and Y is the value, the actual value being used for that variable. So I will start at 0 with 1.9 meters. And the second point will be 40 meters because it will still be flat. And then from there on, it will, to the next point here, is like this 52.5 that I just inserted, 52.5. And this will be then 2.5 meters. So this is what this variation that I would like to see. And then again, so there will be like a flat surface of about 57 5 meters between the two on top of the pier. 70 meters should be again 1.9. And at the end, 110 should also be 1.9. So now we see we have something like this, but I would like this curve to be gradually or parabolic. So I can set a transition from point 40 to the next point 52. You can set it to be parabolic, and it should be horizontal at the beginning, like this. And then the next one from 57 to 70, I would like to be horizontal at the end. So this is the variation. Okay, now if we check the 3D model, nothing will happen yet because I need to assign my table to this variation. So you have full control over it. First, you assign a variable. You can use it just within the section to control multiple elements, for example, values to it, or you can control it with a variation table, or both of them at the same time. So I can still just drag and drop here. You see it will be applied, but now I can still say, no, this should be 10, for example. Yes, so you can still control over each station and each the variation value at that point. So here you can see now being calculated along the variation table, 1.9, 2.5 are the values I entered, but in between this is calculated from this parabolic value. So if I insert another station, it will be automatically calculated. So if I would now apply, then we will see here that my 3D model will now have this gentle variation where we have this 1.9 meter going to 2.5 here. Yes, so let's do something similar for the pier. And then, so pier, I first need to assign a variable to it. So variable, let's say this is pier width. And the pier width default value is maybe 2.2 meters. And then I can assign this value to these parametric lines. Now, you see, I can change one by one. If I assign them to a parameter and assign the other one to the parameter, then you can control multiple lines at once. So if I change this one now, you will see the other one will react also, because both of them follow the same variation that is assigned to these lines. So next step here, again, new table. I will use the same name, doesn't need to be, but easy to understand. And then I start at -15. This is the starting point, the bottom of the pier. And the value here is not 2, but let's say 1 meter. And then at -6, I have also 1. And then at the top, which was -0.5, or -0.5, for example, here, that was correct. And here I will get now this 2.2 meters, for example, 2.2. And again, you can set it like this, or it should go from this point parabolically horizontal at the beginning like this. It could be the other way around also, so you have different possibilities. Now I just need to check if these values correspond more or less with what I've written here. So -15 to 6, and then at the top 0.5. Again, variations. So if we regenerate our model, variation table will be included, or the parameter will be, variation will be included, and I'll just drag and drop, and then you will see here also being calculated. And then a change here, and then our 3D model will be adapted. Yeah, so we've done some couple of steps, going from axis definition to say plan and profile to get the 3D axis, cross-section definition, apply to the axis, pier cross-section definition, apply to a reference point, and then adding variation tables to control how this element behaves. Maybe one small thing, not too much into detail, for the tendons. Cross-section, you can add a point grid, click add it to a reference line, define it here, and then with this you can choose the tendon points like I've described before, to add them and to create tendons along this geometry, and then we'll follow this reference point and also the grid definition. Okay, that's it for this step-by-step example. I have one thing left to show you, and this is the interaction between ALLPLAN and ALLPLAN Bridge. So we'll set this up, and this one here. Maybe there are some questions, Siswanto, that you would like to me to answer.
Yes. Can you create
Okay.
abutment in ALLPLAN Bridge? I think you showed me once, yeah?
Yes. Yes, certainly. That what we showed that yesterday, right? The abutment. I did some freeform modeling.
No,
Oh,
in
you mean ALLPLAN Bridge?
ALLPLAN Bridge, yeah, in ALLPLAN Bridge.
Yes, yes, certainly. Yes, yes. Sorry, I had misunderstood. Yes, certainly. You can define this in ALLPLAN Bridge. Any component. I think there are examples also included that have this abutment. Let's see if I have here one that I opened recently. I think this one here. So you can define this. It's just an element. You can do transversal axis also. And then within the transversal axis, yeah, you see here, for example. So you see this is then the abutment being generated. You have the piers. There is a lot of tendons being included. You can see here all the tendons. So this is then segmental cast. And this is then the abutment. Yeah. Oh, I will make it like this maybe. So this is certainly possible. It then means you need some variations in cross-section, similar for the main girder. You need it also for the abutment. Yes?
Yes, yes,
Okay.
yes. Shows that you can create the abutment. There is one question for the alignment. Can we import data from the civil 3D for horizontal alignment, profile, super elevation? And is that all of the variable can be imported or only horizontal?
Only the axis. So that means horizontal and profile, both of them, but not super elevation. But you can import multiple axes. So if you have a road or a bridge defined by a center axis, an axis on the sides, which define the geometry, you can use this. So this depends. It's not a value that can be imported, but it's the axis. So this depends on the design. Some roads are defined by a central axis and an axis on the side. Yes, this would be possible to use also.
Okay.
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 So
Go
let's
ahead.
go to the last example. And now we'll go here to, this will be a little bit shorter. Which one was it again? This one. So remember yesterday we talked about one of the examples, flyover Kerensheide, this model right here. Oh, I'll move this a little bit again. Yes, remember what we had the piers. We took a look at the end with the definition or the rebar in the pier. You see here now you have this attendance being or also being defined. I have one segment of this that I have prepared in ALLPLAN Bridge. Let's first zoom in here on the different faces. So let's say I have just these two piers and then different faces. So this one and this one, or this one and this one. Yeah, doesn't matter. Okay, so we have this segment, and maybe I make this a little bit smaller. So I have this prepared, and everything we see here, so with the visualization, with the deck, with the car, with the tenants, with also the lamppost and the guardrail here, this is all generated by ALLPLAN Bridge. So there is nothing modeled in ALLPLAN here. And you see this is now straight and flat, no specific design here. And I will open ALLPLAN Bridge already here, ALLPLAN Bridge from this model. And what I would like to do is get it to the point where you have the super elevation, the pier. You have this one pier rotated 45 degrees, at least the foundation. Something else, there is this, the different lampposts are being set. So some modifications that we've seen in the other examples. And now I would like to update. So this model that we have here, so this is ALLPLAN Bridge model with all the tendons included. There are quite a lot of tendons included. And you see this is now straight model. And I would like to get it to the state where it should be and just show as an example how this works to get this model updated. Yeah, so this is now the link between ALLPLAN and ALLPLAN Bridge. So in ALLPLAN Bridge, I will do some changes. So we will change the axis because we see now this is fairly straight. So I will change the curve to have it come to 300. So it's a more visible curve. And I will also change the profile, because now this is flat. And if we check in Allplan, yeah, this is flat. But if we check in this one here, then you see that the height is also being changed. Let's see if I can give this also a different multiple viewports, maybe, that we can see this also here. So animation view, yeah, you see that there is a curve and that it has super elevation and that it's not flat. And there also exchange with this one. And then here, okay. So yes, we have now the different views here. So we need to get this curve and the super elevation in, and the heights also for the profile. So at the start, let's say this should be now 8 meters, and the end should be 5.5 meters. And I would like to have a curve here in the center, which is a radius of 3000, like this. Okay. Now let's maybe update this change already in Allplan Bridge. So you will see now it's curving here, and then also the height is different, but all the tendons, they just follow, right? So there is no need to define anything. If the correct definition has been done for the tendons, then everything will just adapt to it. And you can see this can be quite complex because above the pier, they're close together, but then they spread out again. And this is defined in these variations. So in variations, we have for the tendon different profiles. So horizontal offset, I think this is then a vertical offset, is the spacing between them. So you see this is the curve for the tendon height. And then we have another one where there is a spacing. So depending on the station, it will be closer, so like 40 centimeters apart, or say 25 or 65 distance. So there is at minimum 25 distance, at maximum 65 centimeter distance. This is what we see here. So this is the closest point above the pier. And then in the middle, there is actually a distance of 65 centimeters. So all these parameters have been defined. If something changes, they will just adapt to it. So these are also tendon groups. You see they also are straight at the end to connect with the other tendon. So this is very detailed design and just is being transferred when you do the changes. Okay, now let's do the super elevation. In the cross-section, here, there is this weight savers, and there is also then the angle is included for the inclination. So if I go to the table here, I can set the inclination here. So the 3D model is still flat. I will set the inclination or super elevation to be at the start -5. At this point, it will be -3, and in the end, it will be 0. Yes, so we have, I think this is above the pier. We have some slight change. So if I set it here, then now we will see the super elevation being generated. Yes, so here we see now this all the, again, for all the tendons, this is adapted, so they keep their position within this deck boundary or boundary box. The same thing for the pier. So for the pier, let's say I have the pier, and here for the cross section, I will define that this has also this angle, so -3 there, and for the other pier at the end, I will also say this is minus and then 46. Where do these values come from? You will be able to see this when you check the inclination of the main girder, for example, or the variation. At this point, you see this inclination where the second pier is, for example, with this value. So you can reuse that for the inclination at the top. Okay, let's say there is one more thing I need to do here. In the final design that we have here, you can see that this and this is because there are highways crossing in different directions below it. This foundation is a 45 degrees rotated. Yes, so this can still be easily done. So right now it's just 90 degrees or perpendicular to the axis. I would like to rotate this, and I will do this here in the pier and the variations of the pier 2. So set this to minus 45 degrees, 45. So I will rotate the foundation block in the bottom, independent of the pier. Yes. Okay. So now let's regenerate. Okay, maybe one more change before I do this. We also have the lampposts in Allplan here. You see there is on the car. I will not touch the car, but you see the lamppost. Maybe there are too many. I would just like to have a lamppost here and not this one here, not this one. So one less lamppost. And in Allplan Bridge, this has been defined by variation here. So you see here along the stationing, I put a lamppost, and I don't want to have this one here. So you can just delete the value or write 0. So you can see it just, oh, this is just should be 1. So now there is 1 lamppost, 2 lampposts less. Regenerate model. Not much changing here except for these black arrows, right? So now there is one here, there's one in the middle, one at the end, but there is no intermediate anymore. So I think all the changes have been applied in Allplan Bridge. So let's update in Allplan, update here, and now we'll see the model being updated. So it will adapt the super elevation. This was 1. Let's check here. Super elevation, we have then the radius will be changed. We have the part here where the foundation is changed. We have the profile height, which is changed. You can see from the other direction. Yes, so this should change. We have the piers, which should be different. And all the visualization that we have done already in Allplan will be kept. So that means the textures that have been added to the model, there will be like no need to assign them again. So if you check here in Allplan, so this is like a titanium texture. This is concrete. The road has a surface assigned. This is not something you said in Allplan Bridge. You can assign materials, but this is something I've done afterwards in Allplan to make it good for visualization. So when this is updated, all the changes have been on all the parameters. It's quite a complex change, and this model will then, with one click of button, will adapt and will be updated with all the changes done in Allplan Bridge. Of course, depending on the number of information that is included, this is quite a detailed model. This can take up to a minute or 2 minutes to apply this. So we'll see here when it's ready that also the, say, painting of the road will change. So of course the curve changed. This is aligned to the road deck. It will change. The car position will change. The lamppost position will change. We will have the bearings that will adapt. We will have the tendons that will adapt. So everything will follow this change.
Sorry, Stefan.
Yes.
I need to explain in Indonesia.
Yes.
Ini untuk menjawab pertanyaan tadi, ada yang menanyakan bagaimana untuk memasukkan lampu jalan, bagaimana untuk guardrail dan segala macam. Ini yang ditunjukkan oleh Mr. Stefan. Jadi di dalam Allplan Bridge kita hanya memasukkan referensinya saja, posisinya, terus nanti di dalam Allplan Engineering akan dirubah menggunakan blok tertentu sesuai dengan yang kita minta untuk dipanggil di dalam Allplan Bridge. Stefan, I'm explaining that you are actually calling up a block in Allplan Engineering, and you call it from the Allplan Bridge, right? For the lamp.
Yes, this is the direct link for the lamppost. Yes.
Yes.
Lamppost, car. This also, the tendon, the anchor heads also. They are all objects in Allplan, and you assign them in Allplan Bridge what object you would like to use where, and they will be aligned with the positioning. So yeah, no need to reset anything. But you can define your extensive library in Allplan. I will show this when the update is finished. So here you see now all the changes have been applied. So just one click, only waiting for it to update to be finished. So you have the deck that changed. You have the here the super elevation being changed, radius. The car just need to make sure that it doesn't veer off too much because it's almost at the side. So here also the bearings, they adapt to it. The pier adapts. We have this foundation being rotated. A lamppost, number of lampposts has changed, and the position also. So everything is generated from ALLPLAN Bridge. And for visualization purposes, this is very nice, because if you want to have a different bridge, a little bit quick visualization, there is nothing you need to do. Everything is generated by ALLPLAN Bridge. So where does the components come from? To answer that question, you can have your own library. And in here, you see this, there are just bearing blocks, a car, guardrail elements, and these tendons. So maybe let's look just a little bit into the tendons. So if I set here, turn off everything. So what elements? Yes?
Ivan, can you show how you are using, how you create the road marker, the white colors?
Oh, yes, yes, okay, yes. I will first go through this here, this last thing, so just a couple of minutes more. So we have the elements designed in ALLPLAN Bridge. So we have the main girder with the bearings attached to it, okay. You have the guardrail. There's an element, which also the smart symbols. So if I check this, you will have the solids coming from ALLPLAN Bridge, and then the smart placement, like the bearings, they come from, they are then set with the smart placement in ALLPLAN. Same for the guardrail. So the rail itself is generated by ALLPLAN Bridge, and then the smart symbols, they're being placed by ALLPLAN. And then we have the pier elements. Oh, there, the piers, yeah, just one pier. So this is a different element. You have the other pier, which is foundation being rotated. Let's say the weight saving blocks here, they're also included because they are at specific positions. So this is also something that you can include from ALLPLAN Bridge, and each individual girder or element in ALLPLAN Bridge will be an individual element in ALLPLAN. And then we have the tendons. Let's say I would like to focus here on the tendons. Let's turn off the guardrail here. So the tendons, you see, they align very nicely with the depending, and they follow the orientation of the tendon. So you can set if the tendon needs to be straight. You see, this is almost horizontal. The other one goes a little bit down. These objects, they follow automatically the axis of the tendon. So in ALLPLAN Bridge, you define for a tendon, for example, let's check here just one tendon. And then you define for this tendon here in the middle, you define which one is used. Oh, I'll just select that one here. You define here which anchor is used. So anchor with a different type, with a start and end, because there is a different anchor. And then in ALLPLAN, this anchor is placed. So from the library, you have your end anchor and starting anchor. So depending on, of course, how the tendons will be stressed continuously. So here you see end and start being connected with each other. Okay, let's go last part. So we have the side. This is then a different kind of profile also in ALLPLAN Bridge generated with the side as a cross section. So here, based on the same variable. So for this, you just copy the original cross section and then define. So you have all the right parameter or parametrical lines, and then you just define the shape around it. Can be easily with a chamfer round or like this. And then last point is for the, let's say, the road is the last point here. Guardrail road. So the road are some different elements, and they are built up of, is there also a smart symbol? Yes, that would be the car and the lamppost, but there are some solids, and depending on how it's generated in ALLPLAN Bridge, you can have many different elements. So here, this will probably be many different elements. So you see, this is an element, this is an element, this is also an element. How can you play with that? Let's say you would like to give this a different color in ALLPLAN. So I can just turn off everything here, just turn on the elements you would like to have. And this one, depending on how you manage them or how you handle them, they can have different attributes also. But then you can say, okay, I would like to have these elements to have a different color or a different surface. So this is something that you can play with. Let's say they should have, I'm not sure what this will look like. You can give them a different different color, and then they could look different. Oh, they could look different because this has now, just say here one. I think I picked the wrong element, sorry. Yeah, so by selecting the element, you can give them a different color or different texture. So let's say I would like to assign a different texture to it, visualization. And whenever you do this in Allplan, the changes you make attribute-wise, so adding information to it, or visualization-wise, they will be kept. So let's say I want to make this concrete. I want to make this concrete, for example, like this, just a drag and drop. Then the next update you do from Allplan, this information will be kept. Yes, so you can do the visualization in Allplan and still update your model in Allplan Bridge, send it or do the update in Allplan, everything will be changed, but the visualization that you created already will be kept. So this is a nice workflow where you can do then the parametrical changes, but still keep the visualization in Allplan. Okay, I think this concludes my part of the presentation. Anything else, Iswanto?
I'm okay. So I think we can give it to the PUPR for the link. But before that, Arvid, can you make me as a presenter? I need to share something. Or I can do it myself. I don't know. Let me try. Okay.
Yes, it seems to work. Yes, I can see your screen.
Oke, ini untuk menjawab beberapa pertanyaan juga. Jadi tadi ada teman-teman yang menanyakan contoh-contoh proyek yang sudah digunakan, yang sudah menggunakan Allplan. Jadi di sini ada beberapa sampel dari proyek, tentunya nggak bisa semuanya. Dan tadi juga ada pertanyaan apa perbedaan antara Allplan Engineering dengan Allplan Bridge. Allplan Engineering lebih spesifik dia untuk mengerjain modeling. Jadi dia bisa mengerjain jembatan hanya menggunakan Allplan Engineering tanpa menggunakan Allplan Bridge. Lalu buat apa Allplan Bridge? Allplan Bridge lebih ke arah dia bisa melakukan desain, dia bisa melakukan karena dia sifatnya parametrik. Kalau kita ada alignment daripada suatu jalan, di mana jalannya berubah gitu ya, seperti tadi ditunjukkan oleh Mr. Stefan, sekali kita sudah melakukan pemodelan, nantinya mau dirubah alignmentnya seperti apapun, kita nggak perlu membuat ulang. Kelebihannya begitu. Jadi di sini bisa dilihat beberapa karena masalah waktu juga, jadi nggak mungkin bisa kita tunjukkan semuanya. Jadi ini hanya beberapa sampel daripada proyek yang bisa kami tunjukkan. Masih banyak proyek yang nggak bisa kami tunjukkan karena sifatnya masih tender. Jadi mungkin untuk sekedar memberikan gambaran apa saja yang bisa dilakukan. Jadi ini dilakukan di Allplan Engineering. Jadi ini stasiun high speed rail juga. Bisa dipakai untuk architecture juga. Ini untuk jalan mungkin bisa dilihat ini proyeknya adanya LRT untuk dukuh atas ya. Ini detailnya, jadi di sebelah kanan adalah gambar detailnya. Ini gambar penulangannya. Jadi kalau Allplan Engineering bisa melakukan tulangan, kalau di Allplan Bridge tidak. Ini contoh-contoh daripada proyek. Ini contoh daripada penggunaan Allplan juga. Ini ada contoh proyek juga yang dikerjakan. Ada ini juga contoh proyek juga yang dilakukan. Jadi untuk dam dan segala macam bisa dipakai. Jembatan ini untuk jalan juga. Kembali jalan, jembatan kecil juga ada. Jadi beberapa contoh yang memang saya ambil yang sesuai dengan topik. Ini precast building.